Hi, my name is Mark. I did my paper on the impact of modern consumer society on the future water supply. So I centered my paper around the fact that water is a very limited resource, and because the quality of life of most everybody in the world is going up right now, the water use per person is increasing per capita globally. So in the future, we're probably going to need better purification technologies in order to access new sources of water currently not available to us. So GDP is a measure of production. The higher the GDP, the more production occurs in that area. So currently 20% of the GDP globally is produced in water scarce areas. So this is going to be even more stressed as the population grows and as demand grows. Because as demand grows, production must keep up. So it only takes more water to produce more, and if more and more is produced in these water scarce areas, those local water sources are going to be very stressed. So currently in the Bay Area, 2/3 of its water supply come from outside of the city. It currently has 6 million people, but it's expected to add more than 2 million people by 2040. So this is going to create a highly concentrated highly concentrated population within that area. So meeting the demand for that water supply comes down to finding new sources of water. So what I focused in my paper was wastewater and desalination, and in desalination I specifically focused on microbial desalination. So controlling the waste of water, when it comes down to it, only 2.3% of all wastewater generated is actually able to be recycled and reused currently. So in the future, it would be good, it's essential that all this water is not wasted, that more of it's recycled and used for landscape instead of potable water, or other purposes obviously. And the problems with this water treatment is that in the future, the volume of water that they're going to have to treat, they're not going to be able to do some of their final stages with the land that they have available. So it's really going to become a point of restriction. So in the tertiary stage of wastewater treatment, it's called land treatment. It's one of the last steps in the treatment of wastewater. It purifies the wastewater after bacteria consume most of the other contaminants within it. And the problem with, as I said before, with the cities, is as population increases, they're going to run out of land to put all these, they're called lagoons, to purify this water. So a good solution for the Bay Area is, because they have obviously the ocean, because it would be desalination. So currently desalination costs 5 to 10 times more per cubic meter of water to desalinate versus just drilling an aquifer. And it's because of this fact that the aquifer under the Bay Area it's extremely low. There's not much water in it. This process is extremely energy intensive, and it actually creates a brine byproduct that not many people know what to do with right now. So in the future, people are leaning towards using microbial distillation because it's carried out in a galvanic cell, and it actually creates energy through desalination. So this is what I'm talking about. As you can see, salt water gets dragged through the top of it, or gets sent through the top of the column, passes through the bottom. And as it's sent through, the bacteria, the microbes that are inside, draw the chlorine ions out of the salt water and create a energy potential difference that forces the reaction to completion and renders the water pure towards the end. And and this is obviously not realistic. This couldn't happen over 3 inches. One of these columns is going to be considerably longer. An advantage of this technique, though, is that it shortens the time, and it's actually a very feasible source of potable water because it's actually relatively efficient, and it's also a very feasible source of green energy as well as a result of this. So the disadvantages still, though, are the brine wash is still produced, and it's still relatively expensive to upkeep the cells, but it would be very useful. A possible use for it could be used in making industrial chemicals like hydrochloric acid, or even making a halogen solution for the brine, something like that. I didn't do much research into that. So basically, in the future, water supplies are really going to be dwindling, and how well we can adapt to the new demand for water is going to end up depending on the technology available to us at that time. And here are my references, and that's all I got. Have a good day.